Assalamualaikum warahmatullahi wabarakatuh. Student, today we discuss a most important lecture in real analysis. That one is a theorem, and that theorem is a bounded monotonic sequence is convergent. Now we want to show a bounded monotonic sequence is convergent. First of all, we have two known condition and one is unknown. What are the known? The known conditions are the bounded and second one is monotonic. So according to the given condition, we choose a Sn. Let Sn be a non-decreasing sequence. Here we choose non-decreasing. Non-decreasing we get from monotonic, and the boundedness is given us in this theorem. So we write let Sn be a non-decreasing sequence which is bounded and m equal to supremum of Sn. We can see this one by this example. Let's suppose Sn is a sequence and this sequence is non-decreasing. It means so this sequence is a non-decreasing sequence and it is bounded above. It means this one is the last term of the sequence and that one is 2.5. That is the bounded above. So its supremum is 2.5, that is m, and all of the other values are less than from this value, that is the supremum. So we can say that this result Sn is less than equal to m. It means all of the values are less than the supremum or equal to the supremum. Now if we take epsilon is greater than 0, then m minus epsilon is not an upper bound of the set. What is meant by this one? Student, this one is m. When we subtract a small value from this, let's suppose I choose epsilon equal to 0.5. When I subtract 0.5 from this value, I am go back to this value, that is 2. It means when we subtract some value, we go back and in descending order, and we are on the position 2. So the upper bound is 2.5. This one is not the upper bound. This is written here. If epsilon is greater than 0, then m minus epsilon is not upper bound of the set Sn. And so there is at least one term of Sn which is greater than m minus epsilon. Here you can see there are few more terms that is greater than 2. In this statement, we have, if we subtract 2.5 to something, we have some value that is greater than that value. That means m minus epsilon is less than Sm. Now student, what is the Sm? The Sm is that value that is greater than all of these values. Okay student, if we know that the behavior of these terms, the Sm is same as Sn, because these values are the values of Sn. So the Sm have the same behavior as the behavior of Sn. So we can write this one in this form. If Sm have the same behavior as Sn, so we can write in place of Sm Sn. But within this condition, here all values of Sn, this one is this one, this, all of these are Sn, but the value of Sm are this, and this. If we put n is greater than equal to m, that means we can replace this value by this one, by this condition. So you can see that is very simple. I change the position Sn, move here, epsilon go to another side. This term becomes in this form. Now we can write in modulus form, because this value is positive. Why it is positive? You know m is a greatest value and Sn be any some value less than m. So student, we can write this in the modulus form. Now you know about the modulus form. The modulus form is can be converted in limit form, and this one, the Sn converge to m. This is the overproof of the theorem, that is the bounded monotonic sequence is convergent. Thank you very much for watching Education for All.